Okay, so welcome to lesson 2, the applications of prime factors. To start with, we're going to review what we looked at in our last lesson, and that was how to find the prime factors of a number. So let's look at 48. We can do this two ways. We'll use a table for 48 and we'll draw a tree for 72. So with the table method, I take the number 48 and I put it in the top, and then we start with dividing it by the lowest possible prime factor that will go into it. In this case, that would be 2. 48 divided by 2 is 24. And then 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. And 3 divided by 2 gives me 1. And we stop our division table when we get to a 1 here. So all of these factors, 2, 2, 2, 2, and oops, this one should be a 3. And 3 are our prime factors. So for prime factors for 48, it's 2 times 2 times 2 times 2 times 3. And we can simplify that down to 2 to the power 4 times 3. We need to make a factor tree for 72. So we ask ourselves, what two numbers can I multiply together to get 72? Well, I can multiply 8 and 9 together. And then I'm going to find the factors of each of those. Well, the factors of 8 is 2 and 4. I can't factor 2 down any further because it's a prime number. But I can do 4. Factors of 4 are 2 times 2. So those are prime factors now. And I'll switch over to the right. Find the prime factors of 9. That would be 3 times 3. Those are each prime numbers. So I know the prime factors of 72 are 2 times 2 times 2 times 3 times 3. And I can simplify that by writing 2 to the power of 3 times 3 to the power of 2. Alright, so now let's apply this understanding. So we can apply that. First, we can use this information to help us find the greatest common factor of a number. The greatest common factor of a number is the largest whole number that will divide exactly into the members of the set. So for these numbers, 8, 16, and 20, the greatest common factor for that is 4, because 4 is the largest number that will divide into 8, 16, and 20. Let's take a look at these examples. So I have 15, 25, and 35. Well, because each of these ends with a 5, the best number I would think to divide those by would be 5. 15 doesn't go into 25 and 15 doesn't go into 35. So 5 would be your greatest common factor for that set of numbers. For the second set of numbers, we can write the factors of these numbers. 18, I have 2 and 9. And 20, I have, this can be 2 and 10. So your greatest common factor that is the same between each of these would be a 2. Another way that we can take a look at this is with this one. I have 36 and 54. So with this, what we can actually do is let's build a division table for each of these numbers. I have 36, and let's do a division table for that. So 36 divided by 2 gives me 18. 18 divided by 2 gives me 9. 9 divided by 3 is 3. 3 divided by 3 is a 1. So remember, once I get that 1, that's where I stop. Let's make one for our division table for 54. Follow the same process. 54 divided by 2 is 27. 27 can be divided by 3. When I do that, my answer is 9. 9 divided by 3 gives me 3, and 3 divided by 3 gives me a 1, which is great, but how does this tell me what the greatest common factor is? Well, with this, we can actually, there's a trick to it. We can determine the greatest common factor of them by finding the product of each prime factor, which is common to each prime factorization. So this is what I mean. So if I look at first the prime factorization of 36, I have a 2 here, and I also have a 2 over in the prime factorization of 54. So those are common. So I can put that in my multiplication sentence. And then there's this next 2 here, but I don't have another 2 over here for the 54. So that second 2 is not common between the two. But I have a 3 over here in number 54, and I have a 3 here. So I can add that to my multiplication sentence. And then I can look to see, is there another prime factor that's common? Well, I have a 3 here and a 3 here. So that's common. So I can multiply a 3 there. And I've got a 3 here, but I don't have another one over here on the side where I was doing the prime factorization of 36. So there's only 3 prime factors that are common between these two: 2, 3, and 3. And if I find the product of these, 2 times 3 times 3, well, 2 times 3 is 6, and 6 times 3 is 18. So 18 is the greatest common factor between 36 and 54. All right, so let's use this information to give it a try here. So now I'm looking at the numbers 90 and 225. And if I want to find the greatest common factor between the two, I can use this method of prime factorization. So to start with, let's find the prime factors of each of these numbers. So we'll do a factor tree this time. So for 90, I have 9 times 10 would give me 90. I can then break each side down. 3 times 3 would give me 9. And then on this side, 2 and 5 would give me 10. So the prime factors of 90 would be 2 times 3 times 3 times 5. Well, let's look at the prime factorization of 225. We'll draw a factor tree again. So 225, if I take that and I divide that by, let's say, 25. If I take 225 and divide it by 25, that actually equals 9. So 9 times 25 are 2 factors of 225. And I can take those and break them down into their prime factors. 9 factors of that is 3 times 3. 25, I can break that down into its factors, and that's 5 times 5. Once I get to a point where I have prime factors, I can stop that factoring. So if I write out my prime factors of 225, the answer here is 3 times 3 times 5 times 5. And then what we do is we look to see which numbers are common between them. So do both of these factors have a 2, like as is the 2 in 90? They don't. So 2 is not a common factor between these two. But if I look at my next one, 3, 225 also has a common factor of 3. So 3 is a common factor between them. So I'm going to put that in the start of my division sentence for this. So I've got multiplication. Got 3 there. Look at the next 3. I've got a 3 here, and there is another 3 here. So that can be part of my multiplication to find my greatest common factor. And I can keep moving down the list. So I've got a 5 here, a 5 here, Is there another 5 in the list below? And yes, there is. So I can have 3 times 5. And then if I take a look at this last 5 here, there's not actually another 5 above. So that's not a factor that's common between the prime factorization of each number. And now that I'm at this point, I can actually do the math for this multiplication sentence. So I can go 3 times 3 is 9, and 9 times 5 is 45. Okay, so let's keep applying this. So if I want to find the greatest common factor of the following numbers, 245, 315, and 770, you could do a lot of factoring, take a long time, and figure out the factors of each of these numbers. You could also use our method of using prime factors. So let's draw a table for this one, a division table. So if I draw a division table for each of these, I have 245. 245 has a 5 in the end, so I'm going to take that one and divide it by 5. 245 divided by 5 gives me 49. So now I need to divide that by its lowest possible prime factor. 49 divided by 7 will give me a 7. And then I can also go 7 divided by 7, which would give me a 1. And remember, as soon as we get to a 1 here, that means stop. You don't have to go any further. So let's do the same thing for our next one, 315. Again, it ends in a 5. So 315 divided by 5 is 63. And we have to think about the lowest prime factor that 63 can be divided by. Well, 65 can be divided by 3. When I have 63 and divide it by 3, I get an answer of 21. Lowest prime factor that 21 can be divided by is 7. That gives me 3. 3 divided by 3 is 1. So I got to 1, so I can stop. Stop. All right, let's do it for this last one, 770. So with this one, 770, a good place to start here is 7. This can be divided by 7, which would give me 110. 110, I can divide that by 5. And when I do that, I get an answer of 22. 22 divided by 2 is 11. And then 11 divided by 11 is 1. Again, I'm at a 1, so I can stop. So now let's look at the prime factors of each of these numbers. Let's list them out. So for 245, my prime factors were 5 times 7 times 7. For 315, they were 5 times 3 times 7 times 3. And for 770, it was 7 times 5 times 2 times 11. And so then I'm going to find the factors that are common between these numbers and multiply them together, find the product of them. So my first question is 5 common between them? Well, I've got a 5 here, a 5 here, and a 5 here. So yes, 5 is a prime factor that is common between them. Let's look for the next one. So I have a 7 here. Is 7 common between them? Well, I have a 7 here, a 7 here, and a 7 here. So yes, 7 is common between them. So I'm going to list that in my area where I'm looking at the product. All right, let's keep going. The next one up here is another 7. Is there another 7 in the list for 315? No, there's not. Is there another 7 in the list for 770? No. So that one is not common between them. So since we've looked at all the ones for 245, now let's look at the ones for 315. And Well, because there's only a 3 in this one, that one is also not common between them. And the same with a 2 and the 11 for 770, because there's none in the other two. So to find the greatest common factor between these, I just have to multiply the product of the prime factors that are common to all three numbers. So this would be 5 times 7. So that would mean that my greatest common factor for these three numbers would be 35. Alright, so the last thing we're going to talk about today is how we can use prime factorization to find the least common multiple of a set of numbers. So the first thing, remember that the least common multiple are the lowest, well, it's the lowest multiple that is common between them. So the way to figure it out is to list, commonly, what you've been taught in the past is to list the multiples. So the multiples of 6 was just by counting that number. We have 6, 12, 18, 24, 30, and so on. Then we can do the same thing for 8. Well, the multiples of 8 are 8, 16, 24, 32. Well, at this point, I've already got a number that is common between them, and that is 24. So the least common multiple for this would be 24. All right, let's look at another couple of examples. Let's find the least common multiples between 5 and 7. Well, these are prime numbers, so to find the prime factorization of those, well, you can't really because they are already prime numbers. But for these ones, you would have to list the multiples. So we would go 5, 10, 15, 20, 25, 30, 35, 40, and so on. And then let's list the multiples of 7. 7, 14, 21, 28, 35. Oh, and it's because I've got a 35 up there on the top for the 5 one. There we go. I found my least common multiple. And when you have smaller numbers, it's a little bit easier. When you have maybe a set of 3 numbers or numbers that aren't prime numbers, it can be a little bit more tricky, but we can use our method of prime factorization to determine the lowest common multiples. And to do this, we take all the prime numbers of one of the numbers and multiply that by any additional factors that are in the other numbers. So it looks like this. We find the prime factorization of each number. So I'm going to do a division table for these. 10 divided by 2 is 5. So that 5 divided by 5 gives me 1. So my prime factorization for 10 would be 2 times 5. Let's do the same thing for 12. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 3 is 1. I'm at a 1, so I can stop. So my prime factorization for 12 would be 2 times 2 times 3. Let's do it for 14. 14 divided by 2 is 7. 7 itself is a prime number, so the only other prime number I can divide it by is 7. That gives me a 1, so I can stop. So the prime factors for 14 are 2 times 7. Now remember, we're looking for the least common multiple here. And our rule for doing this is that we can take all the prime factors of one of the numbers and multiply them by any additional factors in the other numbers. Okay, but what does that look like? Well, the number that's common between all of these is this number 2. So I'm going to take the number 2 and I'm going to multiply them by any additional factors that we have. So we also have this being multiplied by 5. So I'm going to take that 2 and multiply it by 5. That 2 also gets multiplied by another 2. So I'm going to multiply that by 2. It also gets multiplied by a 3. So I'm going to multiply that by 3. and it gets multiplied by a 7. So I'm going to multiply that by 7. So when you punch this all into your calculator, 2 times 5 times 2 times 3 times 7, your answer would be 420. So that would be your lowest common multiple of these three numbers. All right, last one here. So we're just going to look at part C in this last class example, and it wants us to use prime factorization to determine the lowest common multiple of 22, 154, and 198. So to start with, let's find the prime factors of each of these, and this time we'll use a tree method. So for 22, the factors of this would be 2 and 11. Those are both prime factors, so I can stop at that point. For 154, well, 2 times 77 gives me 154. 2 is a prime factor, so I can stop, but 77 can be broken down into 7 times 11. Finally, on this side, I have 198. 2 times 99 gives me 198. 99, factors of that are 3 and 33. And then 33, I can also break down to 3 and 11. So now that I've found the prime factors of each of these, I'm going to write them out and then use this to find the lowest common multiple. So the factors of 22 are 2 times 11. The factors of 154 are 2 times 7 times 11. And the factors of 198 are 2 times 3 times 3 times 11. So if I want to find the lowest common multiple, I'm going to first find any numbers that are common between them and multiply those together. So I've got 2 here. I've also got 2's in my prime factorization for the other numbers. So I can have 2. This 2 up here gets multiplied by 11, but 11 is also common to these other ones, so I'm actually going to cross those out there and say, okay, I've got 2 times 11, so I've used up this portion here. Now I'm going to multiply this by any numbers that are not common between them, and the numbers that are not common between them are this 7, this 3, and this 3. So then when I plug this into my calculator, 2 times 11 times 7 times 3 times 3, the answer that you get is 1,386. So the least common multiple of these three numbers is 1,386. So if we just did it the other route, where we were listing all the multiples of 22, all the multiples of 154, and all the multiples of 198, that would actually take you a really long time. But with this method, it becomes a little bit more efficient. That's it for this lesson. We will do part 2 in our next lesson. Thanks.